Hi, Year 6, good afternoon. In computing over the last few weeks, we have been exploring the power that is Bletchley Park and the part in which Bletchley played to reducing the time spent at war through decoding German Nazi messages. So today you are going to be remixing a Scratch project which has been linked under your assignment, and you're going to be remixing this Scratch project which is called Brute Force Emulator. And yeah, I'm calling her the Kapow lady because I'm not sure her name. The Kapow lady will explain what you guys will be doing. So pause the video if you need to as she's talking, and you might want to rewind as well, if that's helpful for you, if it's going a bit quick.
The project uses 6 variables. Variables are items which change as the code is run. In this case, we have 3 variables to represent the 3 digits of our number. Current guess, which is made up of whatever the 3 digits currently are, number of guesses, and 1 variable where the target password is stored. At the beginning of the game, the 3-digit variables are set to a random number to make sure that the number of guesses isn't exactly the same as the number of the password. In a real-life situation, a brute force hack probably would start at 0 and work through every number combination until it found the one it wanted. The number of guesses and current guess has been set to 0 at the start of the game. Within the Data tab, you can select which variables is shown as part of the game. This is currently set to just show the current guess and the number of guesses. By ticking and unticking the boxes, you can show different data within the program. Now let's look at the main script. The program starts with say and ask blocks. Say blocks are found in the Looks tab, and they simply pop up as a speech bubble above the sprite. Ask blocks, however, are found in the Sensing tab as they require an input. In other words, the ask block asks a question and needs an answer before it will move on to the next block of the script. You'll see that the 4th line of the code sets the password variable to whatever the user answer is. This program only works if a 3-digit number is stored as the password, so it's important that the say and ask blocks make it clear to the user that it needs to be a 3-digit number. The next section of the code is a repeat, which creates a value for current guess and keeps adding 1 to it until the value for current guess is the same as the value for password. To do this, we place the code within a repeat until and use a mathematical operator to set current guess equal to password. Within the repeat loop, we start off by changing the 3rd digit by 1. However, we don't want that 3rd digit to ever become more than 10. So you'll notice that the next line of code states that if 3-digit equals 10, then change 2-digit by 1 and set 3-digit back to 0. We want to repeat this code for the 2nd digit too. So if 2-digit equals 10, then change 1-digit by 1 and set 2-digit to 0. Finally, if the 1st digit gets to 10, we simply want to reset it to 0 and start again. Each time the code iterates through this cycle, we count it as a guess, and so we need to increase the total guesses by 1. At the end of each guess, we should have a value for each digit, and by multiplying the 1st digit by 100 and the 2nd digit by 10, we can add all 3 numbers together to make a numerical value which the program can compare with the initial password value. You'll notice that there is a wait of 0.05 seconds at the very end of the loop. This is simply to slow the program down to make it possible to see the emulator try out different options. If you want the program to run faster, either take the wait block out or make it a smaller number, such as 0.05 seconds. The final line of code does something called concatenation, which means joining together different components of code. In this case, we've joined together 3 sentences with the 3 digits of our final answer, along with the final number stored in total guesses. The digits are input individually rather than using the value for current guess, because if the password begins with 0, the 0 wouldn't be displayed using the current guess value. Through this activity, we're aiming to help children understand how to create secure passwords and how brute force attacks can be avoided.
And there we go. There is our amazing Kapow lady. So enjoy this Scratch project, try your best. I know some of you computing might be a challenge for you. Just give it a go. We're not expecting, you know, the most amazing outcome straight away. This is your first time doing this. Don't forget that. Be kind to yourselves and yeah, have fun giving it a go. And we will see you tomorrow.